Here we are on page 2 of Binomial Expansion. I am going to do something a little bit different on this video because there is a lot of writing that goes into Binomial Expansion, and if I don't take time, I write really messy, especially with the pen. So I hope you don't find this too distracting or too fast. Please pause the video whenever you feel that it is too fast, or just slow down the YouTube video. So here we're going to start with number 4a. It says to write down the sixth row of Pascal's triangle. If you remember from the investigation, Pascal's triangle is written by adding up the two numbers above each number. And so you can get the sixth row just by starting with this row and going all the way to the seventh row, right? 1, 2, 3, 4, 5, 6, seventh row. The seventh row has the number 6 in it. That's what they mean by the sixth row of Pascal's triangle, by the way. Find the binomial expansion of x plus 2 quantities to the sixth. When you're going to expand this binomial to the sixth power, the basic template to use is this template here. You can see that in the red boxes I've put the Pascal's triangle coefficients 1, 6, 15, 20, 15, 6, 1, right? I've separated each term with a plus sign. I have put blue triangles to represent the A term because the standard form for a binomial is A plus B. So sometimes we call the first term A and the second term B. And here I have represented each one with either blue triangles for A or brown circles for B, just to make it less confusing, because sometimes we call it A and B will have actual terms which have A and B in them, which is kind of confusing. The other thing I drew these blue triangles and brown circles for is so that you always remember that whatever you put in here should be surrounded by some kind of parentheses, so that it makes it more clear that whatever you put in the blue triangle or whatever you put in the brown circle, you will need to put in parentheses before you square it or whatever. Okay, so let's do the first one. It says to find the binomial expansion of x plus 2 quantity squared to the sixth. And for this case, I am going to generate first the red terms, which correspond to the red boxes, using the Pascal's triangle coefficients 1, 6, 15, 20, 15, 6, 1. Then I am going to put the blue triangle terms, which would be, in this case, the A of the A plus B binomial. It would be x in this case. And what would be the brown circle term, or the B term? It would be 2. So A equals x and B equals 2. Every time I see a blue triangle, I am going to put a x. Every time I see a brown circle, I am going to put a 2. In this case, parentheses are not really necessary because there is only one letter or number in each term. If there were more than one letter or number, then you would want to put parentheses for each one. So, and you notice I also put the exponents 6, 5, 4, 3, 2, 1 descending from the first term to the second to the last term. Why don't I have an x term in the last term? Because x to the 0, as you know, is 1. On the other hand, the brown second term, 2, I don't have one in the first term because it's 2 to the 0. 2 to the 0 is just 1, so I don't need to write that there. And starting in the next one, I have 2 to the first, 2 squared, 2 to the third, etc. On the last one, I have 2 to the sixth, okay, which happens to be 64. Now, you notice I didn't put parentheses here just to make things go faster, but think about putting all these numbers in parentheses to show that they are multiplied. Here, I have actually multiplied everything out and put in the plus signs. You see that everything is separated by plus signs. And I have combined the red 6 with the brown 2 because those are both numbers that can be multiplied together. They form the number 12. 15 times 4 is 60. 20 times 8 is 160, etc. All the way to the last term, which turns out to be 64. Okay? So that's how I formed the answer for x plus 2 quantity to the sixth. Now, what about x plus 1 over x to the sixth? Okay, so here I'm going to do that problem. You notice that here the A value, is the blue triangle value, is x, and the the brown circle value, or the b value, is 1 over x. So in every blue triangle, I'm going to fill in x. In every brown circle, I am going to put 1 over x, and this is what I get here. I get 1 times x to the 6. I get 6x to the 5th divided by x. I have 15x to the 4th divided by x squared, and so on, right? So if I look at the Pascal's triangle coefficients, I once again have 1, 6, 15, 20, 15, 6, 1. If I look at just the blue triangle a values, I have a to the 6th, a to the 5th, and what do I mean by a? I mean the x value here, so it's x to the 6th, x to the 5th, descending powers of x. To the second, to the last term, it will just have x to the 1st, and the last term is x to the 0. You don't need to write x to the 0 because x to the 0 is 1. If you look at in the denominator, I have in the first term nothing because the brown circle value for the first term is 1 over x to the 0. X to the 0 is 0. And so on. And so like the next one I have 1 over x to the 1st, so it's just x. The next one I have 1 over x squared, so I have x squared in the denominator, and so on until the last term, which is 1 over x to the 6th. Then I'm going to rewrite each one of these terms by combining anything that can be canceled or multiplied together. In this case, you can see that, like for example, in this term here, I have x to the 5th in blue divided by x in brown. That reduces to x to the 4th, for example. In this term here, x to the 4th divided by x squared reduces to x squared, and so on. So now here I have the new simplified version. I have x to the 6th plus 6x to the 4th plus 15x squared plus 20. Hey, isn't that weird? The x to the 3rd on top cancels with x to the 3rd on the bottom. I have a constant term right in the middle of the binomial expansion. Here I have 15 divided by x squared. I have 6x divided by x to the 4th. Plus 1 over x to the 6th. Okay, so that is this one, which is kind of unusual because it has like x in the denominator here, which totally changes the powers of the x as you move from the left to the right, doesn't it? Okay, let's look at number 5. Okay, number 5. The first two terms in the binomial expansion are shown below. Okay, so we have a plus b, quantity cubed, equals, and it only gives me first term and the second term, and then after that it says dot, dot, dot. What does dot, dot, dot mean? It just means that the pattern continues on as you can see. Okay, well, maybe you don't see yet, but let's move on. Find a and b. So what are they saying? They're saying, what is the blue triangle and the brown circle value for this binomial? And in this case, we can't really tell because they didn't tell us here, and they didn't give us every single term, so it's not totally obvious, okay? But one thing we do know about a plus b quantity cubed is it does have this form here, which is the Pascal triangle coefficients are 1, 3, 3, 1, as shown here. The a values start from a cubed and descend to a squared, a to the 1st, and the last term, of course, is a to the 0, so you do not write a to the 0. Now the b values start with b to the 0, which you don't write, and then the second term has b to the 1st, third term b squared, and the last term has b cubed. So this is the form for the cubic of power of the binomial, okay? And let's see, let's try to match up the first term with this first term and the second term with this second term. Can we figure out what a plus b are just from these two terms? Maybe we can. Okay, so once we set those equal to each other, let's look at this part first. We have set the a cubed term equal to 8. So we have a cubed equals 8. From this, we could see that a is equal to 2. Right? It has to be equal to 2. And it can't be negative 2 because if it was negative 2 cubed would be negative 8. So we do know it's positive 2. So we know a is 2 for sure. Now we're going to take the second term, 3a squared b. We're going to set it equal to 12e to the x. Okay? So we do that here. Then we already know that a equals 2. So we put the 2 into here and we have 3 times 2 squared. Instead of a squared, we have 2 squared. Then we have b. And then we have that equal to 12e to the x. Now, 3 times 2 squared happens to be 3 times 4, which is 12. 12b actually. 12b is equal to 12e to the x. So now you can cancel out the two 12s from the left and from the right, and you end up with b equals e to the x. Okay, so now we have the value for a, it's 2, and we have the value for b, it's e to the x. So we've finished part A. Part B, hence determine the remaining two terms of the expansion. Well, now that we know that a equals 2 and b equals e to the x, it's pretty easy to figure out what 3ab squared and b cubed are, right? For example, 3ab squared, what you do is you just take a equals 2, substitute that in for a, you substitute e to the x in for b, and then you end up with 3 times 2 times e to the x squared. And remember from last couple chapters, e to the x squared is the same thing as e to the 2x. You can just change the order of the 2 and the x and put the 2 first. What about b cubed? What happens with b cubed? Well, if you substitute e to the x in for b, then b cubed becomes e to the x cubed. Remember that e to the x cubed is same thing as e to the 3x, okay? And remember, oh, I forgot to simplify. 3 times 2 to the e to the 2x is actually 6 times e to the 2x, okay? So we have, for the third term, 6 e to the 2x. For the last term, we have e to the 3x, okay? All right, now let's look at number 6. Number 6. All right, first we're going to look at 6a. It says to expand and simplify this binomial here, 1 plus square root of 2 to the third. Now, this isn't even a binomial with a variable, but that doesn't matter. You can still expand this binomial the same way you've expanded all the other binomials. So, first thing you can do is, you want the Pascal's triangle, I put it in red here. The Pascal's triangle coefficients for cubic are 1, 3, 3, 1. So I have red 1, red 3, and red 1. Then I'm going to take the a term, or the blue triangle term, which is 1, and I am going to put that in each term. And it's going to start with 1 cubed for the first term, 1 squared for the second term, 1 to the first for the third term, and 1 to the 0 for the last term. But you notice that 1 to the third, 1 squared, 1, or 1 to the 0, all equal to 1. So the first term, 1, doesn't really need to be done anything with. You could just not ignore it, right? Now what about the second term, which is square root of 2? The square root of 2 is the b term, and the square root of 2 term starts out being square root of 2 to the 0, which is just 1, then square root of 2 to the first, which is square root of 2, then square root of 2 squared, and square root of 2 cubed. So I've written out each one of the terms. I haven't put the plus signs in yet. I should put plus signs in between. I'm going to do that in the next line here. So now I have plus signs in between each of the 4 terms, and I have simplified some of these. For example, the purple square root of 2 squared here, square root of 2 times square root of 2, the definition of square root of 2 is if you multiply it times itself, you get 2. So square root of 2 squared is 2. 3 times 2 is 6. So the third term is 6. The last term, square root of 2 cubed, you could say, well, if I have square root of 2 cubed, that's square root of 2 times square root of 2 times square root of 2. The first 2 square root of 2's multiply together and give you 2. And the last square root of 2 just stays by itself because there's no other square root of 2 to multiply it times. You have a integer times a radical here. Then you could take these 4 terms and try to combine them into an integer term and a square root of 2 term. So I'm going to take the 6 and add it to 1 and get 7. And then I'm going to take 3 square root of 2's and add them to 2 square root of 2's, and I'll get 5 square root of 2's, right? So that is how I simplified this expression here. Let's go to C. Now we have 2 minus the square root of 2 to the 5th. Again, we have an expression which basically has numbers and no variables, but we can still expand it as if it was a binomial, okay? So in this case, the blue triangle term, or the a term, is 2. The brown circle term, or the b term, is negative square root of 2. Now be careful here, because since this one is not plus, you need to group the minus sign together with the square root of 2, and always consider that when you put in the b term anywhere, you are actually putting a negative square root of 2 there, okay? What happens when you do that? Well, basically it forms kind of a nice little pattern where the terms alternate. Instead of being plus, 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 plus all the time, they're going to alternate from minus, plus, minus, plus. Because if you have the b term to the fifth power, that would be an odd number of times you're multiplying the negative sign, so you're going to end up with a negative result. If you have square root of 2, negative square root of 2 to an even power like 4 or 2, then the negatives are going to multiply times each other an even number of times, and then you're going to end up with plus, right? Okay. So in this case, we have the Pascal triangle coefficients for the power of 5 written here in red. And if you look at the power of 5 row, it's 1, 5, 10, 10, 5, 1. We can find the power of 5 row because the second number is 5. Okay, so we write down the red coefficients here, and then we are going to put in purple the a term, which is 2, to the first to the fifth power, then to the fourth power, then to the third power, and the second power, and the first power, and so on. So that's why we go 32, 16, 8, 4, 2, 1. Okay? Then the b term is negative square root of 2, right? So if we have negative square root of 2, in the first term, we're going to have negative square root of 2 to the 0 power, so there's nothing there, it's just 1. In the second term, we're going to have negative square root of 2 to the first power, which is just going to be negative, and there's the negative, and then the square root of 2 here. So the negative I wrote in red here, and the brown square root of 2 is the square root of 2 part. Now, if we have in the next term, we're going to have negative square root of 2 to the second. Now, if we square the negative, it becomes plus. If we square the square root of 2, it's square root of 2 squared, and that eventually is going to become 2, right? And so on. And if you look at the last term, we of course have the b term to the fifth power. And the b term to the fifth power, you can see that the negative to the fifth power would be a negative, okay? And square root of 2 to the fifth power would simplify into, let's see, it would be square root of 2 times square root of 2 times square root of 2 square root of 2. It's like square root of 2 5 times, right? So 4 of those square root of 2's are going to combine into 2 times 2, which is 4. And then the remaining square root of 2 is just going to be by itself here, square root of 2. So I have a simplified row here where the first element becomes 32, and the second term you can see becomes 5 times 16, which is 80, times square root of 2, okay, and so on, all right? And if you combine all the integer terms together and all the square root of 2 terms together, you end up with 232 minus 164 times square root of 2. Okay, number 7. Now we're going to expand 2 plus x quantity to the 6th. Okay, now in this case, we are going to first put the Pascal's triangle coefficients, which are 1, 6, 15, 20, 15, 6, 1, right? Then we are going to take the a term, or the blue triangle term, which is 2, and we are going to first take it to the 6th power, then the 5th power, then the 4th, then the 3rd, then the squared, then the 1st, and then the 0th power. Okay, so that's why we get 64, 32, 16, and so on. Then we're going to take the b term, which is plus x, and we are going to take it to the first power, then the second power, and the third power. So, we're going to take it to the 0th power in the first term. So x to the 0 is just 1. Then here we're going to have x to the first, and then here we're going to have x squared, x cubed, and so on, all the way till we get to the last term, which is x to the 6th. Now, I didn't put the plus signs in between yet, but when I do that, like in this next row here, I'm going to have 64 plus, and then I have 192. How did I get 192? It's 6, red 6 times purple 32. That gives me 192, and then, of course, the x comes down too. And then I multiplied all these numbers together. The red 15 times the purple 16, the red 20 times the purple 8. I just wrote it in different colors here because it helps keep track of what is the Pascal's triangle coefficient, what is the a term, what is the b term, and so I didn't have to make a billion parentheses, okay? But, you know, when you write this in pencil, you want to put parentheses in between everything to show that they're multiplied together, right? So, finally, after I expand it here with all the x's and all the numbers multiplied together, part B says use the expansion to find the value of 2.01 to to the 6th. And you're like, well, what does this have to do with the binomial? Well, if you look carefully, you can see that the 6th power matches for both. And then here that you have 2 plus 6, here instead of 2 plus x, here instead of 2 plus x, you have 2.01. Well, 2 plus x, if you set that equal to 2.01, you can see that what they're saying is that x is 0.01. So if x is 0.01, then we're going to basically put 0.01 in for each one of these x terms, and we're just going to get a big expansion here. So you can see that like 64 is not multiplied times any x, so it's just 64. 192 is multiplied times 0.01. So 0.01 times 192 becomes 1.92. 240 is multiplied times x squared, which would be 0.01 times 0.01, which would be 0.0001. And if you multiply those together, you end up with 0.024. And so on. You can see that these get super small as they go on, right? Okay. Finally, if you add them all together, you get this number here, 65.9441606021201. Okay. Whew. Number 8. Expand and simplify 2x plus 3 binomial times x plus 1 to the 4th binomial. Okay. When you do this, you are going to do the binomial expansion first, and then after that you're going to save this multiplication for last, because there's not really any good easy way to do that, okay? So, to do x plus 1 to the 4th, we are going to use Pascal's triangle coefficients, and we're going to identify the a and the b terms, and we're just going to expand it like we usually do, okay? Now remember, x plus 1 to the 4th is going to be the 14641 Pascal's triangle row, this one here. And we're going to expand it out 14641 of the coefficients. And then the a term is x, and the first term is going to have x to the 4th, right? X to the 4th. The next term is going to be x cubed, then x squared, then x, and then x to the 0. Now, the b term is just 1, so b doesn't really do anything. b to the 1st, b to the 4th, b to the 3rd. If it's 1, 1 to the 3rd, 1 squared, 1 to the 4th, they're all just 1, right? So you don't even need to write down the b term. So I don't write down the b term. So I end up with this here, okay? Then I'm going to multiply this polynomial, x to the 4th, times 2x plus 3, right? The way you do that is kind of like a megafoil. So, for example, first you're going to take 2x and you're going to multiply it times each one of these terms. So you're going to have 2x times x to the 4th. You're going to have 2x times 4x cubed. You're going to have 2x times 6x squared. You're going to have 2x times 4x, and then you're going to have 2x times 1, right? Then you take the second term and you're going to have 3 times x to the 4th, 3 times 4x cubed, 3 times 6x squared, 3 times 4x, and 3 times 1. Okay, when you do that, you're going to end up with the red polynomial and the purple polynomial. The red polynomial is a result of you taking 2x and multiplying it times each one of these terms, right? So, for example, the first term, 2x times x to the 4th, you can see that that becomes 2x to the 5th. There it is right there. If you take the 3 here and you multiply it times each one of the terms, you're going to have 3x to the 4th, 3 times 4x cubed, which would be 12x cubed, and you can see it right there. So if you write out the red polynomial and the purple polynomial shifted by 1 like this, you can see that all the terms line up. So the x to the 4th lines up, x cubed lines up, x squared lines up, etc. So now I can just add them in columns, right? And when I add them in columns, it's a little bit easier to keep them straight. And I can just add the coefficients here. So 8x to the 4th plus 3x to the 4th becomes 11x to the 4th. Okay? So that's how you get the new polynomial, which is actually 2 polynomials added together. Okay? These problems are a little bit challenging. Okay, now we're going to number 9. These are interesting problems because what they're doing is, instead of asking us for the entire binomial expansion, which would be 6 separate terms added together, they're asking us for one specific term. And they do this a lot in IB exams because it takes a long time to write out 6 terms. And in the IB exam, they don't want to waste a lot of time with you doing things that are repetitive. Okay, so let's try to figure out how we would do this problem. So remember that the Pascal's triangle expansion for 3a plus b to the 5th would look something like this. The Pascal's triangle coefficients are in red, 1, 5, 10, and 10, 5, 1. I only wrote down the first 3 terms, and you'll see why later. And then I'm going to have the blue triangles starting with the 5th power and descending to the 0th power. And then I'm going to have the brown circle coefficients, and the brown circle coefficients are going to start with brown circle to the 0, brown circle to the 1, brown circle squared. What do the blue triangle and brown circle mean? Blue triangle corresponds to the 3a, it's the first term, right? And now you can see why I use blue triangle instead of brown circle and brown circle, because like if I use a and b, that might get confusing because here the a term or the blue triangle term is actually 3a. It's not just a. So I think that's kind of confusing, so that's why I'm using these other symbols. So in for every blue triangle, I want to put 3a. In for every brown circle, I want to put b. And you can see that if I do put 3a in the blue triangle, and if I put b in the brown circle, I am going to see in this particular term here, I'm going to see a cubed and b squared, right? Because there is an a in the blue triangle, it would end up being a cubed, and there is a b in the brown circle, and that would become b squared. And that's exactly what they want. They want to know the term that is a cubed and b squared, and that will be this term here. Okay, so now I can just ignore the other terms and concentrate on this term. Red 10, blue triangle 3 to the 3rd, brown circle squared. Now I'm just going to put in my 3a and plus b and the b into the blue triangle and the brown circle. Okay, and so you can see I'm concentrating on this term here, and I'm going to fill everything in. So the 10 stays 10. The blue triangle cube becomes 3a parentheses cubed, and the brown circle becomes b squared. Okay, and then I'm just going to multiply out all the numbers. So the 10 multiplied times 3 cubed, which is 27, is going to become 270. Then a cubed times b squared is the variable part. And you can see that we have indeed figured out the term that is the a cubed b squared term, and they want the coefficient of it. So basically what we say is, okay, the coefficient is 270. And that's it for 9a.